You are listening to the Vocal Technologist. Spoken tech for your ears.
You know, I was trying to spin up a quick automation script last week, and I swear I spent 40 minutes just wrestling with this one single, totally opaque encoding error.
Oh, I've been there.
It wasn't even the logic, it was just this foundational headache. I felt like I was debugging something from, I don't know, 2005, not 2025.
That experience is, that's precisely what the industry is working overtime to just eliminate.
It has to be.
Yeah. Every major trend we've seen in the material from, language updates all the way up to these massive AI platforms, it's all focused on one thing.
Which is what?
Aggressively optimizing performance and just systematically stamping out human error with better code and smarter machine learning.
Right. So for our Tech Tuesdays exploration today, the mission is pretty straightforward. We're going to unpack a whole stack of recent technical updates, all about efficiency, observability, and AI automation.
Giving you the fastest route to getting up to speed.
Exactly. This is your shortcut to understanding what's really changing the game in platform engineering.
And what we're seeing is this real professionalization of automation. It's not enough just to build infrastructure anymore. It has to be secure, self-healing, and automatically efficient.
The role of the engineer is definitely shifting.
It is. And everything we're about to talk about connects right back to that one evolution.
Okay, so let's unpack this by starting at the very core. The programming languages that build everything. Python is, it's still dominant.
Oh, absolutely. Data science, ML, automation.
So when we see updates for something like Python 3.15, why do those little details actually matter for a developer's day-to-day?
Well, the speed improvements from the JIT, the just-in-time compiler, those are significant for, raw performance.
Sure.
But the bigger strategic win, I think, is the unified profiling module. It's moving performance optimization out of the realm of just guesswork.
And you're talking specifically about the new Tachyon sampling profiler.
Exactly that. Before, finding a bottleneck could feel like a complete black box exercise. Now, a sampling profiler like Tachyon gives you this incredible visibility and precision into what's happening at runtime. You can see exactly where the CPU cycles are being wasted.
So you're optimizing based on actual data, not just a hunch.
Precisely.
And I can't just skip over the boring but vital housekeeping stuff. That automatic shift to UTF-8 as the default encoding. That sounds so mundane, but that one change could wipe out an entire class of those frustrating low-leverage errors that have plagued developers for, decades?
It's a huge quality of life improvement. And speaking of developer confidence, we have to mention the rise of Rust.
Right.
While Python is getting faster, Rust's adoption is accelerating because its whole foundation is reliability and performance. The big takeaway is that its tooling and memory safety features, they just give developers the confidence to tackle huge problems.
So you can ship code without worrying about whole categories of common bugs.
Exactly. That confidence is absolutely essential when you start to scale up, which brings us to Cloudflare.
Okay, so how does a massive organization manage hundreds of different production accounts securely without it just becoming a total compliance nightmare?
Well, they moved to a massive infrastructure as code model.
So Terraform and a custom CI/CD pipeline.
Right, across all those accounts.
Yeah.
But the crucial insight here is how they implemented this radical shift-left security approach. They stopped checking for security after deployment.
They started creating security policy as code. I know they're using the Open Policy Agent, OPA, and the Rego language for that.
And it's a complete philosophical shift. It's programmatic. They've codified something like 50 critical security policies inside OPA.
And the system checks everything automatically.
And more importantly, it requires peer reviews before the code can even be merged, let alone deployed.
That sounds counterintuitive to me. Managing 50 policies in a language like Rego seems like it could create its own complexity. What's the hidden cost there?
The cost is upfront, for sure, but the return is huge. The old model was expensive too. You just paid for it with security risks and manual audit.
Right.
By moving enforcement to the commit stage, you minimize the chance that one tiny human error leads to a massive security lapse down the line. You're trading manual effort for automated preventative governance.
Okay, so we've covered writing safer code and enforcing security before deployment. But we all know the truth. Even perfect code on perfect infrastructure, it still fails.
Inevitably.
Which takes us to observability. What happens when things break?
That's where the industry is seeing the biggest push towards, intelligence. Take Grafana Labs in 2025. Yeah, they had the Grafana 12 release, but the real story is the integration of machine learning into the stack itself.
You mean the AI-powered Grafana assistant and adaptive telemetry? What does adaptive telemetry even mean in practice?
It means the monitoring system gets smarter about what it watches and how it watches it. It's no longer just about showing you dashboards.
It's about smart analysis.
Exactly. It surfaces anomalies without you having to tell it exactly what to look for.
Yeah.
And that capability is so necessary because, frankly, traditional logging is just failing engineers in these complex distributed systems.
And what's fascinating is why it's failing. The logs are noisy, they're low context, and they're engineered to be written quickly.
Right. Optimized for storage, not for answering high-stakes debugging questions.
So when an outage hits, engineers get thrown into what one analysis perfectly called grep-based archaeology.
I love that term. You're just sifting through billions of lines of text, desperate for a clue.
What's the solution?
The solution that's gaining traction is this idea of wide events, or canonical log lines.
Okay, so instead of scattering hundreds of little low-context events everywhere, you generate one massive, context-rich event for each request.
It's high cardinality, high dimensional. Think of it like a comprehensive medical chart for a patient's entire journey through the system instead of hundreds of separate little notes.
But the volume must be insane.
It is, which is why they use tail sampling.
Oh.
It intelligently picks out the events that matter most, like errors or high latency requests.
And the payoff is transforming debugging from that painful archaeology into fast analytical queries.
Exactly. And speaking of fast analytical responses, this is where it gets really interesting. Meta has taken automation all the way to incident resolution itself.
Ah, you're talking about their root cause analysis platform, DRP.
Yep.
This isn't just alerting. This is programmatically automating the entire investigation.
It's cognitive automation. It runs 50,000 analyses every single day, used by over 300 teams.
So instead of a human checking 10 different dashboards,
DRP executes the diagnostic playbooks to figure out the probable cause.
the impact on mean time to resolve, the MTTR, must be huge.
It's astonishing. We're talking a 20 to 80% reduction.
Wow.
That's a massive time saving. But the bigger story is the roadmap. This platform is set to evolve into a fully AI-native system. It's accelerating Meta's whole AI4Ops vision.
So the human is taken out of the immediate response loop. Their job becomes writing better playbooks.
Exactly. Defining the system's behavior, not manually running diagnostics.
That shift from using AI to diagnose problems to using AI to actively improve the code itself, that feels like a huge paradigm change.
It is, which leads us right into GitHub's continuous efficiency system. The ambition here is just fascinating.
It's a combination of AI automation and green software principles, right?
Right. And the goal is to make code bases truly self-optimizing for performance, efficiency, and sustainability.
A self-optimizing code base. That sounds like science fiction. How does a human engineer even maintain control of that?
Through what we call agentic workflows. This is the new architecture we sometimes talk about here on Vocal Technologist. The human engineer stops fixing every little piece of code.
And becomes the rule author.
Exactly. They write natural language rules. Things like, ensure all function calls in this module use async, or never allow config drift in this file.
And the AI agents just go and apply those rules across hundreds of repos.
So the human provides the high-level intent, and the AI handles the low-leverage grunt work.
And we're seeing that same kind of AI optimization solving bottlenecks at the very end of the cycle, too, with end-to-end testing.
Which is notoriously brittle and slow.
Oh, it's a huge pain. But now, some teams are using AI to write, run, and maintain the entire E2E test suite.
And the mechanism is the key. The AI uses these auto-healing locators.
So it finds elements by their description, not by a brittle XPath that breaks every other week.
Game changer.
Yeah.
It cuts defect escape rates by an average of 89%, and you can cover critical user flows up to 75% faster, all with plain English tests. It just takes the tedious part out of testing.
You know, we've talked a lot about huge organizations like Meta and GitHub, but sometimes a massive impact comes from just one focused, low-level optimization in the open source world.
That brings us to the fantastic work done on the Kyverno CLI.
Which came out of an LFX mentorship.
It did, and it was all about a very specific targeted optimization of their policy engine.
The details are technical concurrent loading, namespace caching, deferred discovery, but the result.
The result is absolutely mind-boggling. They reduced the time it took to apply policy on over 3,000 resources from a grueling 15 minutes.
15 minutes?
Down to 1 or 2 seconds.
That's not just a speed increase. That's a structural change. That means a pipeline can run dozens of times a day instead of once.
Right. And that kind of efficiency is also what you need when you're dealing with massive data scale, like server access logs.
Yelp had this problem with their S3 access logs. The volume just made cost and query speed a huge engineering problem.
And their solution was pure, smart data engineering. They built a cost-efficient pipeline, and the crucial move was compacting all those raw text logs into Parquet files.
It sounds dry, but it's a brilliant choice. You're basically taking thousands of scattered documents and compressing them into one highly organized, super searchable data format.
That's it. And the dividends were enormous. It cut their total storage by 85%, and critically, reduced the object count in S3 by 99.99%.
Wow.
That object count reduction makes querying for debugging, for cost analysis, for compliance, it makes it incredibly fast and cheap. Sometimes the biggest win is just choosing the right data format.
So before we wrap up, just a quick nod to a bit of web security history. It's been 10 years of really crucial stability.
We're talking about Let's Encrypt.
Yep.
They just celebrated a decade,
Yeah.
and their growth has been phenomenal. They've become the world's largest certificate authority in that time.
It really just shows the power of the community driving towards simple, free, and universal HTTPS.
It's a vital piece of open source infrastructure for the whole modern web.
It really is.
So after all that, what does this entire stack of updates actually mean for you?
For your career, your project.
The overarching theme, I think, across everything is this aggressive professionalization of automation.
Yeah.
We saw security policy automated at the commit stage with OPA at Cloudflare.
Right.
We saw incident investigation being delegated to Meta's DRP platform. And we saw code maintenance becoming a self-optimizing task handled by GitHub's AI agents.
It feels like the engineer's highest leverage role is just fundamentally shifting. You're moving away from fixing code and manually debugging systems.
And you're moving toward authoring the rules and the intents for the AI agents.
Whether that's a security policy in Rego or a natural language instruction for a code bot.
Precisely. And this knowledge helps you figure out where to invest your learning time. It should be in the tools that let you do critical thinking and architectural design, not manual, repetitive process.
The systems are getting smarter about handling their own operational burdens.
Yeah.
So here's a final thought for you to mull over. If we can trust AI agents to apply natural language rules that result in code bases and platforms that are genuinely self-optimizing, what's the next frontier of non-coding, high-leverage work for the human DevOps engineer?
What's the complexity that only you will be able to solve?
Something to think about. Thank you for joining us for this exploration of technical efficiency.
We'll catch you on the next one.
Spoken Tech for your ears.